Welcome to Trinod chemistry classes. In this video, I am going to discuss about intermediate second year chemistry topic organic compounds containing nitrogen. This is my 8th video in this topic of organic compounds containing nitrogen. In the first 7 videos of this topic, I have discussed about amines, what are amines, what are the how amines are classified, how to name amines, and how to prepare amines by various methods, and some of the chemical properties of amines were also discussed. In this video, I am going to discuss about aniline, which is aromatic primary amine. We know that the molecular formula of aniline is C6H5NH2. C6H5NH2, and its structure is in benzene. One of the hydrogen is replaced with NH2. So we know that aniline is prepared from nitrobenzene. When nitrobenzene on reduction with tin by HCl or Zn by iron by HCl, it gives aniline. Aniline is prepared by the reduction of nitrobenzene by using the reducing agent such as tin by HCl or iron by HCl. And the aniline, the reactions of the aniline are categorized into two types. One is reactions involving the NH2 group. The chemical properties of aniline are discussed in two ways. One is the reaction of NH2 group, reactions of NH2 group in aniline, and the second one is reactions of benzene. So in the reactions of NH2 group, whatever in my previous videos I have discussed, that is, one is alkylation. When aniline is treated with alkyl halide, it forms N-alkyl aniline. Similarly, acylation means when aniline is treated with acetyl chloride or acyl chloride or acetic anhydride, it forms N-phenyl amide. So this is the acylation reaction. Then the third one is reaction with nitrous acid. When aniline is treated with nitrous acid or NaNO2 by HCl, it forms benzene disonium chloride. When aniline is treated with nitrous acid or HNO2 by HCl, it forms benzene disonium chloride. Then we have seen carbylamine reaction. When aniline is treated with chloroform and alcoholic KOH, isocyanate, phenyl isocyanide is formed. This reaction we are calling it as the carbylamine reaction or isocyanate test. And this carbylamine reaction is used to distinguish primary amines from secondary and tertiary amines. Then we have seen the reaction of aniline with aniline with Hinsberg reagent. Reaction with Hinsberg reagent. So these are the 5 reactions of aniline with various reagents. In all these 5 reactions, the reacting part is NH2 group. The reacting part is NH2 group. In this video, I am going to discuss about the reactions of aniline which involves the participation of the benzene group. We know that the molecular formula of benzene is C6H6 and its structure is like this, and it undergoes electrophilic substitution reactions. So like benzene, aniline also participate in electrophilic substitution reactions. Aniline also participate in electrophilic substitution reaction. If we observe the resonance structures of aniline, NH2, due to presence of lone pair of electrons, on nitrogen, due to presence of lone pair of electrons on nitrogen, it participates like this, and we get a resonance structure like this. And here there is a negative charge and NH2 plus. There is another movement like this. We will get one more resonance structure like this, minus, and this is the double bond NH2 plus. So here this bond is positive. Here we are getting positive charge and positive, negative, and forming a double bond. Then third one is like this. So if we observe the resonance structures of benzene, here we are getting negative charges at ortho and para positions. That's why this NH2 group in aniline is ortho para directing and ring activating group. Ortho para directing and ring activating group. Here, the NH2 group is a ortho-para directing. The aniline also participates in undergoes electrophilic substitution reaction. The NH2 group in aniline is an ortho-para directing, and it is a ring activating group. When further electrophilic substitution reaction, the incoming electrophile goes either to ortho position or para position and is much more reactive than the benzene. Now, let us discuss some of the reactions of the aniline which involve the electrophilic substitution reactions. When aniline is treated with nitric acid. In the presence of H2SO4. We know that HNO3 plus H2SO4 is called nitration mixer. It forms three products. One is para-nitroanilin and meta-nitroanilin and ortho-nitroanilin. So here para-nitroanilin is the 51% will be formed. Whereas meta-nitro, which is 47% is formed, and which is ortho-nitroanilin is 2% will be formed. Is formed. So if we observe, just now I told that I have discussed that NH2 group is ortho-para directing, and the whatever incoming electrophile comes either in ortho position or para position. So, but here we are getting around 47% of the meta product also. The reason is in the presence of acids. NH2 group, in the presence of acids, they form positively charged, positively charged anilinium ion, which is meta-directing, which is meta-directing, which is meta-directing. That's why when aniline on reaction with nitration mixer, we are getting paranitro-aniline, meta-nitroaniline, and orthonitroaniline. So why we are getting meta product? Even though NH2 group is ortho-para-directing, we are getting meta product as the second major product. The reason is in acidic medium, aniline molecule gets protonated and forms anilinium ion. This anilinium ion is a meta-directing group. This anilinium ion is a meta-directing group. That's why we are getting meta-para-nitroaniline, meta-nitroaniline, and orthonitroaniline. So the 51% of the para-nitroaniline, 47% of the meta-nitroaniline, and 2% of the orthonitroaniline. So this is the one of the electrophilic substitution reaction of aniline. So aniline on reaction with the nitration mixer, it forms a mixture of para, meta, and orthonitroanilines. Here para-nitroaniline is 51% and 47% of the product is meta-nitro and 2% is only orthonitro. The formation of meta-nitro product, even though NH2 group is ortho-para-directing, 47% of the product is meta-nitroaniline. That reason is due to in the presence of acids, aniline forms anilinium ion. That's why it is becoming meta-directing. It is becoming meta-directing. So this is one of the electrophilic substitution reaction of aniline. So this reaction is important not only for intermediate public examination point of view, and is also important for any kind of entrance exam such as FSET, MSET, or NEET, JEE mains, such entrance exams. Then second one is sulfonation. Sulfonation. Aniline on reaction with sulfuric acid. On reaction with sulfuric acid. Initially, it forms a salt, NH3 plus HSO4 minus. HSO4 minus. This on heating at 455 to 475 Kelvin. 455 to 475 Kelvin. It forms NH2 SO3H. Sulfanilic acid. And which interconverts to vitriol. NH3 plus and SO3 minus. Aniline on reaction with sulfuric acid initially forms a salt like this, and which on further heating at 455 to 475 Kelvin, it forms sulfanilic acid, and sulfanilic acid reforms as a deuterion like this. It is a deuterion. It consists of both positive and negative charges. Forms a deuterion. So this is the second reaction of electrophilic substitution reaction of aniline. Second electrophilic substitution reaction of aniline. Now the third one is bromination. We know that benzene on reaction with chlorine or bromine in the presence of Lewis acids, such as AlCl3 or FeCl3 or tin chloride, it forms chlorobenzene. Similarly, if the same reaction in the presence of Lewis acids forms bromobenzene. Here, this reaction doesn't occur if Lewis acid is not present in the reaction mixer. Lewis acid not present in the reaction mixer. So due to presence of activating group such as NH2 on the benzene ring, bromine, the benzene on aniline on reaction with bromine water. Aniline on reaction with bromine water, it forms 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Tribromoaniline. Aniline on reaction with bromine water. On reaction with bromine water. 3Br2. On reaction with bromine water. So this is 1, 2, 3, 4, 5, 6. So it forms 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Here, due to the high reactivity of the NH2 group, we cannot isolate the either ortho-bromoaniline or para-bromoaniline. Finally, we are getting 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. Here, the NH2 group present in the aniline is a electron donating group. That's why it is an ortho-para directing and ring activating group. Ring activating group. So now, question is it possible to get ortho-bromoaniline and para-bromoaniline, or can't we prepare this ortho-bromoaniline and para-bromoaniline by using this electrophilic substitution reaction? Means this can be done by decreasing the reactivity of the aniline. The high reactivity of aniline is due to the presence of lone pair of electrons on nitrogen. If we able to decrease the availability of lone pair of electrons on nitrogen, then we can we can control the reactivity of the NH2 group. So first, aniline we need to convert into N-phenyl histamine. Conversion of aniline into N-phenyl histamine. Aniline to ortho-bromoaniline or para-bromoaniline. So how to get aniline to ortho-bromoaniline or para-bromoaniline? So when aniline is treated with bromine water, it forms 2,4,6 tribromoaniline. So is it possible to get aniline to para-bromoaniline and ortho-bromoaniline? So this conversion involves the two steps. First, we need to convert aniline to N-phenyl histamide. So N-phenyl histamide. So when aniline is treated with acetic anhydride, it forms N-phenyl histamide. So this N-phenyl histamide on reaction with bromine, it forms ortho-bromo N-phenyl histamide and para-bromo. Like this. So this on further hydrolysis, it gives ortho-bromoaniline and para-bromoaniline. So here in the conversion of aniline to ortho-bromoaniline and para-bromoaniline, aniline to ortho-bromoaniline and para-bromoaniline. There are two steps. There are two steps. One is conversion of aniline to N-phenyl acetonide. Aniline to N-phenyl acetonide. We know that NH2 group in aniline is NH2 group in aniline is highly ring activating and orthoparadirecting due to involvement of lone pair of electrons on nitrogen in the resonance with the ring. As a result, we are getting aniline on reaction with bromine water. It forms 2,4-6 tribromoaniline. To get a monobrominated product, monobromo product, so it is necessary to decrease the ring activating effect of NH2 group. Ring activating effect of NH2 group. So we need to decrease the ring activating effect of NH2 group. This can be done by acetylation of aniline. Aniline on reaction with either acetic anhydride or acetyl chloride, it forms N-phenyl estamide. N-phenyl estamide. This N-phenyl estamide on bromination forms orthobromo product and para-bromo product, which on further hydrolysis gives orthobromoaniline and para-bromoaniline. So during the reaction with acetyl chloride or acetic anhydride, what is happening? So the basic idea during this conversion is when due to the high reactivity of the NH2 group, when aniline is treated with bromine water, it forms 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. So if you want to get monobromo product, we have to, it is necessary to decrease the, ring activating effect of NH2 group. Ring activating effect of NH2 group. So this the ring activating effect of NH2 group can be decreased by means of acetylation. So when aniline is treated with acetic anhydride, or acetyl chloride, it forms its corresponding amide, histamide, NH2, C double bond with CH3. So whatever N-phenyl histamide is formed, so in that the lone pair of electrons on nitrogen, in resonance with the carbonyl group present in the amide, CO minus and CH. Hence, the availability of lone pair of electrons decreases. That's why its ring activating effect also decreases. When during the acetylation, what is happening is, it is during the, when aniline is treated with acetic anhydride or acetyl chloride, it forms N-phenyl histamide. In N-phenyl histamide, the lone pair of electrons participate in the resonance with the carbonyl group of the amide, and it forms like this. So hence the availability of lone pair of electrons decreases, hence its ring activating effect will be decreased, hence it forms orthoparadirecting and orthobromoaniline and para-bromo derivative. Orthobromo derivative and para-bromo derivatives, which on further hydrolysis gives orthobromoaniline and para-bromoaniline. So these are the reactions of aniline which are involving benzene ring. So aniline normally in the reactions, chemical reactions of aniline are divided into two types. One is the reactions involving NH2 group and the reactions involving the benzene ring. In the reactions involving NH2 group, whatever in my previous videos and 6th, 7th and 5th videos, I have discussed alkylation, acylation, reaction with nitrous acid and carbylamine reaction, and then with the Hinsberg reagent, all those reactions are the reactions which involve the NH2 group of the aniline. In these reactions, whatever aniline undergoes, like benzene, aniline also undergoes electrophilic substitution reaction, and aniline is more reactive when compared to the aniline is more reactive when compared to benzene. The reason is due to the availability of lone pair of electrons, due to the availability of lone pair of electrons in benzene. So in NH2 group, the NH2 group in aniline is highly ring activating and orthopara directing. Why it is? Due to involvement of lone pair of electrons on nitrogen, lone pair of electrons on nitrogen in the resonance. So this is about the reactions of benzene. Thank you for watching. Please like the video, share and subscribe the channel.